Whoa, see that guy right there? Looks like he's hit rock bottom. Well, that guy's actually me. Now, I bet you're wondering, how did I get in this wacky situation? To tell that story, we have to go back. Way back to the start of the project lab for EM271 Electrical and Mechanical Techniques and Design 2. The project in question has been assigned by an oil and gas company. They need us to design a device to measure the thickness of a steel vessel where there is suspected corrosion. We designed and built a circuit that transmits and receives an ultrasonic pulse. Ultrasound has lots of uses, from marine and sonar imaging to medical devices. To measure the thickness of the steel, ultrasound will be transmitted into the steel, reflected off the other side, and then received. The circuit was made from two main elements, the transmitter and the receiver. The transmitter circuit had to perform three functions: generating the pulse, inducing a delay, and triggering the transducer. The pulse was generated by this unijunction transistor design. It is then passed through a comparator for conditioning. The delay was induced by utilizing the propagation delay of 4 NAND gates. The transducer trigger was made from a MOSFET transistor, allowing a small logic pulse to control the 15 volts required to power the transducer. Meanwhile, the receiver circuit would amplify the received ultrasonic pulse, condition the pulse into a more appropriate waveform, and convert the converted waveform into a TTL logic pulse. To amplify the waveform, we used an amplifier. This amplified the voltage from 50 mV to an approximately 1 volt waveform. This waveform was then conditioned through a passive rectifier. Lastly, the waveform was converted to the TTL pulse by passing it through the comparator. The project was complete, and we even had some leftover time to make some festive decorations.